Look up at the night sky. What do you see? You see a snapshot of the universe in a moment of brilliance. Countless stars glitter across the darkness, each a sun, some larger and brighter than our own. Galaxies, vast islands of light, swirl in the cosmic ocean. We live in a vibrant, youthful universe. It is a time of immense energy, a time of creation, but have you ever wondered what happens when this all ends? What is the ultimate fate of everything we see? This is not a question about human lifetimes or even the lifetime of our planet. It is a question about deep time, a scale of time so immense that our human minds struggle to grasp it. It is the story of the universe's final chapter. This story begins not with a bang, but with a slow, silent fade. To glimpse the distant future, we must first appreciate the present. Our universe is currently a magnificent spectacle of light and energy. The fundamental actors in this cosmic drama are the stars. Stars are giant nuclear furnaces. Deep within their cores, immense pressure and temperature force atoms of hydrogen to fuse together, creating helium. A star's life is determined by its mass. The more massive a star is, the hotter it burns and the faster it consumes its fuel. The most massive stars live fast and die young. They burn through their hydrogen in just a few million years before exploding in spectacular supernovae. Now let us cast our minds forward in time. Let us travel beyond the age of our sun, and even the age of our galaxy as we know it. We are journeying to the end of the stelliferous era. Imagine looking at the night sky 1 trillion years from now. The great star-forming nebulae will be long gone. The universe will have stopped making new stars. The sky will grow darker and redder. The massive, brilliant blue stars will be the first to disappear. The longer-lived stars will be the last to go. One by one, over trillions of years, they too will exhaust their fuel, leaving behind their cooling white dwarf cores. The universe will be filled with these stellar ghosts. Every story has a beginning. For a star, that beginning is a cold, dark cloud of gas and dust. These are the stellar nurseries of the cosmos. Gravity, the great sculptor of the universe, begins to take over. It pulls the gas and dust together, slowly but relentlessly. Finally, after millions of years of slow collapse, the core reaches a critical threshold. Nuclear fusion begins. This is the moment a star is truly born. A new light has been switched on in the universe, one that will burn steadily for millions or even billions of years to come. Once a star is born, its life is a constant, delicate balancing act. It is a battle fought over millions or billions of years between two fundamental forces of nature. A star's life story is almost entirely determined by one single factor: its mass. The amount of matter it gathered during its formation dictates how long it will live. For most of its life, a star exists in a long, stable phase known as the main sequence. During this time, it is steadily fusing hydrogen into helium in its core, but this stability cannot last forever. Eventually, the hydrogen fuel in the core will begin to run out. The star's long, peaceful life comes to an end. For the vast majority of stars, including our own sun, the end is not a violent explosion, but a slow, graceful transformation. The star swells into a red giant. Our sun, in about 5 billion years, will do just this. It will grow so large that its outer atmosphere will swallow Mercury, Venus, and possibly even Earth. The star begins to pulsate, gently puffing its outer layers away into space. These expanding shells of gas create one of the most beautiful objects in the cosmos, a planetary nebula. What remains at the center is the star's exposed core. This is the white dwarf. A mass roughly half that of the sun is crushed into a sphere the size of the Earth. While most stars fade away gently, the most massive stars go out with a bang. These are the giants of the cosmos, stars born with more than 8 times the mass of our sun. Inside the core of a red supergiant, a frantic sequence of events unfolds. The star fuses heavier and heavier elements, creating an onion-like structure within. When the core becomes pure iron, the star's fate is sealed. With no more energy generation to hold it up, the iron core collapses catastrophically. This titanic explosion is a supernova. For a few weeks, the dying star shines with the light of 100 billion suns, briefly outshining its entire home galaxy. As we journey deeper into the future, the universe continues its slow, inexorable fade. The night sky is now dominated by the faint, ruddy glow of the universe's last surviving stars, the red dwarfs. These tiny, cool stars are the true marathon runners of the cosmos. While a star like our Sun will live for 10 billion years, a red dwarf can shine for trillions. But even these marathon runners cannot last forever. One by one, over trillions of years, they too will exhaust their supply of hydrogen and fade away. The last light from a fusion-powered star will finally go out. The stelliferous era is officially over. This is the true beginning of the degenerate era. Imagine looking up at the sky 100 trillion years from now. The dominant objects in this new sky will be the white dwarfs, compressed stellar cores the size of Earth. As these white dwarfs age, they slowly radiate their heat into space. After trillions of years, their light will shift from blue-white to yellow, then to orange, and finally to a dull, faint red. A white dwarf is made mostly of carbon and oxygen, arranged in a crystal lattice structure. It is, in essence, a gigantic crystal floating in space, literally a diamond in the sky. The night sky of the degenerate era will be a spectacle of these stellar diamonds, the only significant sources of light in a galaxy that has otherwise gone dark. While the stars are dying, the galaxies themselves are also undergoing a profound transformation. Our own Milky Way galaxy is on a collision course with the Andromeda galaxy. This cosmic dance will eventually form a single giant elliptical galaxy, which astronomers have nicknamed Milkomeda. The universe's expansion is accelerating, driven by dark energy. Distant galaxies will be receding from us at ever-increasing speeds. Eventually, they will cross a cosmic horizon, their light no longer able to reach us. Our magnificent universe will be reduced to a single, isolated island of matter in an endless ocean of darkness. The degenerate era has truly begun. The only significant light comes from the white dwarfs, but these objects are not producing new energy. They're simply glowing with the immense heat left over from their former lives. This cooling process is unimaginably slow. A white dwarf is very small, so it doesn't have a large surface area from which to radiate its heat, allowing it to hold onto its heat with remarkable efficiency. Imagine floating through this future galaxy. It would be a place of profound darkness, punctuated by these lonely, fading points of light. The galaxy would be a silent graveyard. This period, which will last for quadrillions of years, is the longest, most stable, and perhaps the final significant era of light in the universe. As a white dwarf continues its cooling process, something remarkable happens within its core. Under extraordinary conditions, the atoms can no longer exist as a gas and lock into a fixed, rigid structure. The white dwarf begins to crystallize, transforming into a single, gigantic crystal. It is, in a very real sense, a diamond the size of a planet. The universe, in its old age, will be filled with these cosmic jewels. Our own sun is destined to become one of these magnificent objects. The process of crystallization has a fascinating effect. It temporarily slows down the cooling process, as if the white dwarf is taking one final gentle breath before continuing its descent into darkness. The journey of a white dwarf does not end with crystallization. After quadrillions of years, even the faint red glow will be gone. Its temperature will have dropped to just a few degrees above absolute zero. At this point, it will no longer emit any significant heat or light. It will have become a cold, dark, inert lump of matter, invisible to any observer. This final object is known as a black dwarf. The term black dwarf is, for now, purely hypothetical. The universe is nowhere near old enough for one to have formed. Imagine the universe at this point. It is a place of almost perfect darkness and cold. They emit no light. They generate no heat. The cosmos has finally become a place of profound silence and stillness. The birth of the black dwarfs marks the end of the degenerate era. As the universe sinks into eternal night, the story of matter itself takes a strange turn. According to some theories of physics, even protons are thought to have a finite lifespan. Over timescales of 10 to the 34th power years, the protons that make up the black dwarfs will fall apart, each decay releasing a minuscule puff of energy. The magnificent planet-sized crystals would slowly evaporate. The very substance of the universe would be slowly unmade, returning to a simpler, more primordial state. All complex structures would ultimately be erased. The universe would be returning to a state of almost perfect simplicity. In a universe where all stars have died, could there be any source of energy left? The last remaining bastions will be the black holes, the final actors on the cosmic stage. Stephen Hawking discovered that black holes are not entirely black. Due to quantum effects, they slowly emit a faint glow of thermal radiation, now known as Hawking radiation. This slow evaporation represents the very last source of energy in the universe. For an almost infinite duration, these evaporating black holes will be the only hotspots in the universe. When the last black hole finally evaporates in a final tiny flash of radiation, the universe will have reached its end state, the heat death of the universe. In this unimaginably distant and dark future, could anything that we might call life survive? The degenerate era seems utterly hostile to life as we know it, but perhaps we are limited by our imagination. Some scientists have speculated about how life might adapt to these extreme conditions. These would be beings of pure energy, their existence spread across vast regions of space and unimaginable stretches of time. Their lives might consist of computations so slow that our entire universe would be but a single thought to them. It challenges us to think about what life truly is. The universe's capacity for complexity and consciousness might not end when the last star dies. We have journeyed to the furthest reaches of time, to the very end of the universe's story. We have watched brilliant stars fade and die, leaving behind a sky of ghostly white dwarfs. This cosmic narrative leads to an ultimate state of cold, dark, and featureless emptiness. It is a story of cosmic endings, a universe returning to the void from which it came. However, there is another way to view this cosmic story. An ending does not necessarily invalidate the journey that came before it. A beautiful piece of music is no less beautiful because it eventually falls silent. The story of the universe is about the incredible richness and complexity that emerges along the way. The fact that the universe can produce beings capable of contemplating their own existence is profound and wonderful. Thinking about the end of the universe forces us to confront the immense scale of cosmic time. We find ourselves living in a very special, privileged moment, the glorious age of stars. We have the extraordinary privilege of being able to look up at a night sky filled with galaxies and nebulae, to witness the birth and death of stars. The knowledge of the universe's eventual fate can fill us with deeper appreciation for the present. Knowing that the stars will not shine forever makes the night sky seem more beautiful and profound. We are the universe's way of observing itself. The atoms forged in the hearts of long-dead stars have come together to form conscious beings who can marvel at the cosmos. The story of the universe, from its fiery birth to its cold, dark end, is the grandest narrative we know. It is a tale of epic transformations, of unimaginable timescales. It is a story that we are only just beginning to piece together, using the light from distant galaxies and the intricate language of mathematics. What this journey ultimately leaves us with is a profound sense of awe. To contemplate a future of black dwarfs and evaporating black holes is to stretch our minds to their absolute limits. We exist. We can think. We can wonder. In a universe destined for an eternity of cold silence, the fact that there is a fleeting moment of warmth, light, and consciousness is a miracle of cosmic proportions. The story of what happens when only white dwarfs remain illuminates the preciousness of the present, the beauty of the temporary, and the enduring power of human curiosity to reach out and touch the void. And in doing so, to feel an unforgettable sense of wonder.